All right, welcome to another lesson video. Today we're starting day 7.1, our introduction to Unit 7. In Unit 7, we're going to be talking about surface area and volume. And when we talk about surface area and volume, we're referring to three-dimensional figures. But before we do that, we're going to do a lesson here on 2D figures or two-dimensional flat surfaces, like shapes that include polygons and circles. And we're going to talk about area, composite area, perimeter of those kinds of shapes, because that's going to lead into future lessons, okay? And if you read carefully in this notes packet, hopefully you're following along with that. Your test is going to have another equations portion. So there's a lot of equations used here. So please make sure you're paying attention to those as we go. You'll find those on the very last page of the notes as well. And so with that being said, we're going to start off with some basic formulas for area today. One of them, this first one, you'll remember from the last unit, hopefully, the area of a circle. Remember, our equations and formulas start with something like A equals, capital A for area. Okay, so the area of a circle, remember, is pi r squared. Okay, where r is the radius, distance from the center to any point on the circle. All right, if you double that radius, you get the diameter. But that's our area formula. All right, now as we look through these, I'm actually going to not go in order, at least not left to right, top to bottom. I'm going to kind of jump around because some of these are figures that you've seen before and hopefully remember the formulas for those figures. Like for a rectangle, hopefully you remember that the area of a rectangle is length times width. Okay, this cursive L is what I use for my length. Okay, and there's my width. Okay, notice those are perpendicular dimensions. Okay, they're perpendicular to each other. There's a right angle formed by the length measurement and the width measurement. Okay, so whatever the length is times whatever the width is gives us our area. Now, I do want to point this out to you before we move on to another figure. If I were to mark a corner or opposite corners of the rectangle here, and if I were to connect those with a diagonal, I'm cutting that rectangle in half. Okay, that top triangle is equal to this bottom triangle. They're each half of the rectangle. So the area of that triangle would have to be that length measurement times the width measurement divided by 2. Okay, or half of length times width. Well, that leads us to our formula for area of triangles. Since I'm going to erase that much of it, and we will talk about triangles. Okay. So if you look at the triangle, I haven't marked a length and width measurement, but I've marked a base and height measurement, okay? And the relationship between base and height always has to have this right angle marked, okay? Because base is always perpendicular to the height, okay? This symbol upside down, capital T, means perpendicular, all right? So the area formula for a triangle, it's like it's half of a rectangle. So it's 1/2 base times height, or base times height divided by 2. That's the other way you can write that formula. Either way will work. Okay? Which leads us to another figure. A square is a more specific kind of rectangle. So it's still length times width, but the length and width are both the same side length. They're both S. And so a square's area formula is just side length times side length, or side length squared. Okay, side length to the second power. All right, that leads us to these two. Let's talk about a parallelogram. A parallelogram is very similar to a rectangle. It looks like it's just slanted. In fact, okay, they give you these dimensions, base and height again. If I were to take this height measurement and kind of cut that out, cut that triangle out, and then move that triangle over here, you'll notice it gives us a rectangle. Okay, where the length is actually this base, it's like your length, and the height is like your width. So the formula for area of a parallelogram, instead of length times width, it's just base times height. And base and height, again, in any of these figures, if I'm giving you a base measurement and a height measurement, they are always perpendicular. Okay, base is always perpendicular to height. And that leads us to our trapezoid. Now, a trapezoid is a four-sided figure. We call that a quadrilateral, but it's not a rectangle. It's not a parallelogram. It's not a square. There's only one pair of opposite sides that are parallel. We call those the bases. In this case, we're going to split them into base 1 and base 2. Okay? Now, notice there is a height measurement between those two that is perpendicular to both bases. Okay, so still, base and height are perpendicular. Both bases are, in fact, this time. So here's our area formula. Because there's two different bases, essentially what we're doing is taking the average of the bases times the height. Remember that to take the average of something, you add them up and divide by 2, or divide by how many there are. So the area formula for a trapezoid can be written a couple different ways. This is the most common way. 1/2 times the height measurement times the sum of the bases, B1 plus B2. Okay? Again, you can write it that way, or you could write it as base 1 plus base 2 all times height, all divided by 2. That's the other way you could write that formula. But it's the same calculations, just kind of written in a different order. And so there's your basic area formulas we're going to use today. Okay, so make sure you have those written down. But we also want to talk about perimeter. Okay, in general, to find the perimeter of any polygon, you just add all of the sides together to get the total distance. Okay, so when we add all the sides together, we call that the sum of the sides. All right. Let's take a look at finding some area calculations with these shapes. Okay, the first thing you really need to do is identify what kind of polygon or what kind of shape you're dealing with. This is a rectangle. Okay, and the area formula of a rectangle is length times width. Okay, so this is my length, this is my width, or vice versa. Really doesn't matter which one is which. And we're just going to multiply those then. 4.7 times 3.9. Okay, so when I multiply those, I get 18.33. The directions above do say to round to the nearest tenth, so we'll just say the area is about 18.3, and then our unit of measure would be square meters. Okay, let's move right along. This next shape is a parallelogram. If at any point in the video I'm going too fast, just kind of pause, make sure you're giving yourself time to catch up. So with our parallelogram, we use our area formula that is just base times height. Now remember, base and height are always perpendicular. So you see this right angle, that tells you this measurement is your height, and it's perpendicular to this side or perpendicular to a line containing the opposite side there. They're both 8.3. So that's your base. Okay? So my area is that base of 8.3 times the height of 6. So we do 8.3 times 6, and we get 49.8 square yards. All right, let's keep going. And this is our first example of our trapezoid. Okay, in this trapezoid, we've got our bases that are perpendicular to that height measurement. You should be able to notice this is the height measurement. Okay, it connects one base to the other base. So these are your bases, base 1 and base 2. So since this is a trapezoid, the area formula for a trapezoid is 1/2 height times base 1 plus base 2. Okay? So that would be 1/2 times the height of 7. I use parentheses for multiplying there. You don't have to. We can do a times dot and then parentheses for this, if it makes more sense. Base 1 I've already called 3.2. That means base 2 is 9. The order of those, again, doesn't matter. You can flip those around. Either way, you're still going to get the same result when you add them. And so that's what I'm going to do first. I'm going to add those together first. I could plug all this into the calculator, but when I try and do everything in the calculator, sometimes I skip things and make mistakes, so I'd rather do it one step at a time. 9 plus 3.2, or 3.2 plus 9, is 12.2. Okay? And then we're going to do, I'll just do 7 times 12.2 first. Okay, so that is 1/2 times 85.4. And then I'm going to do half of that. And the way I do half of that is just to divide by 2. Okay, I just think of it as 85.4 divided by 2. Okay, and you get 42.7. And that would be square yards for the unit of measure. Okay? All right, for these next couple, I'm going to have you pause the video and I want you to try these bottom three of the table on your own. Okay, we've got a circle, a triangle, and then a square at the end. I want you to pause the video, try and work these out using those formulas. Okay, you've got your formulas above on the page. And then when you're ready to continue to check your answers, go ahead and push play. If you need more time, keep the video paused. Otherwise, this is what you should get. For the circle, we do area equals pi r squared. 9 is the radius. So 9 squared is 81. 81 times pi gives us about 254.5 square kilometers. Okay, for this next one, this triangle, I want you to be careful of this one. If you did this one wrong, you probably used 5 as your base. But remember, base doesn't necessarily mean bottom. The base and the height are perpendicular. Okay, so you look for this right angle symbol. These two segments are the ones that form the right angle. That means the base is 8 and the height is 4.3. Okay, looking for that height measurement that is perpendicular to a side is how you're going to determine what the base is. So be careful of that. So if the base is 8 and the height is 4.3, that means 8 times 4.3 over 2 is our formula, because we do base times height divided by 2. And when we do that, we get about 17.2 square meters, or meters squared. And lastly, with our square, remember the area of a square is just s squared, or side length squared. So we take that 3.8 times itself, or 3.8 squared, and we get 14.44. Now that is an exact value that kind of cuts off on your calculator. There's nothing following that. There's no repeating or extended decimals. So we could just use that as our answer, but the directions did say to round to the nearest tenth. And so if you did that, you got just 14.4 square meters. All right, let's go ahead and continue on with the next page of the notes. And this time we're going to go into a little more detail with the formulas. In these problems here, I give you certain information about a specific shape, and I actually want you to use the formulas to work backwards and solve for the missing measurement. Okay, so it's really important we write the original formula starting with A equals, because most of these require us to plug in for A. Okay, so the first one is a trapezoid. We're going to underline that, and then I'm going to start with the trapezoid formula. Okay, a trapezoid formula is area equals 1/2 height times the sum of the bases. Base 1 plus base 2. All right, and then I'm going to plug in what I know. This time they tell you the area is 29.5. So instead of A, I write 29.5. Equals 1/2, and then we're going to look at the height. They give me the height. They say the height is 5, so h is 5. And they tell me one base measures 8 yards. So it doesn't really matter which one of these I plug it in for. Let's say I plugged it in for B1. The first base is 8. That means I'm looking for the second base, B2. Okay, the length of the other base. So when I look for that, okay, this B2 is going to be what I solve for. Okay, now when you have an equation like this where there's a 1/2, I could do 1/2 times 5, or half of 5, do 5 divided by 2 and get a decimal. I really want to avoid that. The trick I use anytime there's an equation that has a 1/2 in it and I'm solving that equation, meaning working backwards to get some variable by itself, I'm going to cancel that 1/2 by multiplying both sides by 2. Multiply by 2 here to cancel the 1/2. So I multiply by 2 on the other side to balance it out. Okay, I automatically write the times 2 on that side, and then I cross the 2 and the 1/2 out so I know it's not there anymore. The left side we can actually change and simplify. When I do 29.5 times 2, we get 59. The 1/2 is no longer there on this side, so I just have 5 parentheses, 8 plus B2. And now I can go about solving this. There's a couple ways to do this, but what I would probably do, and most of you would too, is do 5 times 8 and 5 times B2. Remember to distribute to both. When we had some equations like this in the last unit, we were forgetting to distribute to both of those when I was looking at some of your work. Okay, so we do 5 times 8. I'm going to come up here because I have more room. So 59 is still on the left. 5 times 8 is 40. And then we just have plus 5 B2. Okay, now we're going to start to get B2 by itself, that base variable by itself, by doing minus 40 to both sides. Gives us 19 equals 5B2, or 5 times B2. And then we divide by 5. Okay, when we divide by 5 here, that means that the other base gives us about 3.8. Okay, and the unit of measure here is just yards. not yards squared. We only found one length measurement, not the area. Okay, so here, let's try another one. Number 2, same idea. We're given a triangle this time, and it has a given area of 23 square inches and a height measurement of 5.1 inches. Find the measure of that base. Okay, there's only one base, it's a triangle. I don't really need to draw a picture here. What I can do is just use the formula. The area of a triangle formula is base times height divided by 2, or over 2, like that. So I'm going to plug in what I know. Instead of A, I know the area is 23. I don't know the base, but I do know the height is 5.1. So I plug in that for H, still all over 2. Now again, because this formula has a 1/2 in it, or a divided by 2 in it, that's what I want to cancel out first. So again, I'm going to multiply by 2 in my very first step to cancel out that divided by 2, or cancel out that 1/2. So I multiply by 2 on the left to keep it balanced. So that gives us a new equation. 2 times 23 is 46. And now the right side of that is only b times 5.1. And all we have to do now is divide by that 5.1 to get rid of it. Okay, so we're going to do 46 divided by 5.1. And we get a longer repeating decimal that is about 9.01. So we'll just call it 9.0 to the nearest 10th inches. Okay. All right, so here's what we've got now. Number 3, we've got a parallelogram. Has an area of 13.1 square kilometers and a given base of 4.5 kilometers. You're supposed to find the height. I want you to pause the video here and try this one on your own as well. When you're ready to check your answer, push play. All right, this is what we should get. For a parallelogram, your area formula is base times height. So A equals base times height is what I start with. And that means I use 13.1 for my area, and my base is 4.5. So all I really have to do is divide by 4.5 on both sides, and I get 2.9 kilometers. All right, one final one, and this one actually goes pretty quickly. It says find the area of a sheet of paper measuring 8.5 inches by 11 inches. That's kind of your standard sheet of paper. So the area of a sheet of paper, okay, is the area of a rectangle. Most sheets of paper are rectangles. That's what we can assume. So the area formula is length times width, or 8 times 11. In fact, it's given to you in those dimensions. 8 inches by 11 inches means 8 times 11, which just gives us 88 square inches. All right, so let's move on to our next couple problems. It says find the side first, then find the perimeter of each given shape. Okay, so we're going to start with the area measurement of a specific shape, in this case a square, and we're going to work backwards to find the side and then use that side to find the perimeter. Remember, the perimeter is just the sum of all the sides. So if we know the area is 400 square inches, I start with the area formula for a square. Remember, the area of a square is side squared. Don't use length times width. Okay, we know that both sides are the same as each other, so I want to use the more specific area formula for a square, and that's area equals side squared. And the area is 400. So really, you're asking yourself, what number do I square to equal 400? Well, in order to find that answer, using the algebra here in this equation, we take the square root of both of those. When I do the square root of 400, I get the side length is 20. The square root of 400 is 20. So that means I can use that side length to find my perimeter. Remember, the perimeter is just the sum of all the sides. Okay, side plus side plus side plus side, because the square has 4 sides, but they're all the same, right? So it could be like doing 4 times the side length, or in this case, 4 times 20, which is 80 inches. Okay, so let's move on to our next one. It says find the perimeter of a rectangle. This time it is just a rectangle with an area of 400 square inches if the length is 25. We need this statement, otherwise we can't do this problem, because we want to start with the area formula for a rectangle, which is length times width. Well, they tell you the length is 25 and the area is 400, so 400 equals 25 times the width. So I've got to find out the width by working backwards. Divide by that 25. Okay, when I do 400 divided by 25, I get that the width is 16. So then the problem is asking me to find the perimeter. Well, perimeter is sum of the sides. Well, there's two lengths to a rectangle and two widths, or 2 times the length plus 2 times width is a simplified version of that. Well, that's 2 times the length of 25 plus 2 times the width of 16, giving me 50 plus 32, which is 82 inches for this perimeter. Okay? All right, so you'll notice here between these two, when I go from a square to a rectangle, when I change the dimensions, I make one side a little longer, one side a little shorter. Even though the area stays the same, the perimeter can increase. Okay, and there's a pattern to this that you could get into and look at, that there gets to be a point where the perimeter is no longer getting smaller, it's getting bigger, or vice versa. It's no longer getting bigger, it's getting smaller. Okay? All right, so now let's take a look at another concept. We've been talking about rectangles, squares, triangles, parallelograms, trapezoids, even circles, but there's a whole other category of polygons called regular polygons that we've seen show up quite a bit in previous units. In a regular polygon is where all sides are congruent. Okay, there's a specific area formula that we are going to write down. Okay, we'll put it there, but I want to talk to you about what that looks like first. There's two main parts to that, something called the apothem and something called the perimeter. The apothem, A-P-O-T-H-E-M, not apothem, apothem, it's a segment from the center of a circle, or sorry, center of a regular polygon drawn at a right angle to a side, like this, from the center at a right angle to the side. That's called the apothem. We use a lowercase a there. Well, we use a lowercase a because if I used a capital A, that'd be confusing because capital A represents our area in all these formulas. So we want to use a lowercase a in this formula. That's the apothem. The other part of the formula is the perimeter. Okay, and you guys know what perimeter is. Okay, perimeter is the sum of all the sides. However, because all the sides are the same, perimeter is equal to the side length times the number of sides. Okay, so here's the area formula for a regular polygon using the apothem, lowercase a, and perimeter, capital P. The formula for area of a regular polygon is 1/2 apothem times perimeter. Or another way to write that is area equals apothem times perimeter divided by 2. Okay? We take that apothem length and that perimeter, multiply them, divide by 2, and that gives you the area of a regular polygon. So let's apply that. Let's practice this. To find the area of this regular polygon, we want to start with that formula. Area equals 1/2 apothem times perimeter. We have the apothem marked here. Sorry, I kicked my laptop stand. We have our apothem marked here. 19.1 is your A, your little a. Okay? So it's 1/2 of 19.1 times, I've got to find the perimeter. Well, each side of this polygon is 22 inches, and there are 6 of these sides. If n equals 6, my perimeter is the length 22 times 6, which is 132. So that's my P. Now I can do these calculations. Okay, I'm going to do this in this order. I'm actually going to do 19.1 times 132, and then I'm going to divide all that by 2. And so we get a fairly large value for our area, but that's okay. We get 1,260.6, and we don't have a unit of measure, so we can just write that number. All right, let's try another one. Same idea. Apothem equals 1/2, or sorry, area equals 1/2 apothem times perimeter. They give you the apothem, 13.7. We got to find the perimeter. Well, to know the perimeter, look at how many sides there are times the side length. So the side length is 10, and there are actually 9 sides here. If you're having trouble counting this, we want to start with one side and actually mark it 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that way you make sure you don't double count one or stop one too short. So there's 9 sides. N equals 9. So we take that side length of 10 times the number of sides 9, so the perimeter would be 90. So my formula turns into 1/2 of 13.7 times 90. So I do 13.7 times 90, and I divide by 2, and I get 616.5 for the area. All right, in these last two on this page, we've got the name of the polygon given. Again, the name is going to tell you how many sides there are. Now, you may not remember all of these, so I'm going to help you out. A nonagon has 9 sides. Okay, 9-sided polygon is called a nonagon. And again, it's a regular polygon. So if the side length is 6.8 and there are 9 sides, I can find the perimeter first. Perimeter would be the side length 6.8 times 9, which is 61.2. Okay, so my perimeter is 61.2. So now I use my area formula again. Okay, area equals 1/2 AP. So area equals 1/2 of the apothem, that's this, times the perimeter, which I just found there. And now I can do that calculation. 9.4 times 61.2, and then divide by 2, giving us about 287.64, or I can just call it 0.6 and round to the nearest tenth. Okay? All right, one more. A pentagon. We should hopefully remember that, but if you can't remember, the prefix penta means 5, so a pentagon is a 5-sided polygon. There are 5 sides, each one is 9.4 for side length. So the perimeter is 9.4 times 5, giving us 47. So the area is 1/2 apothem times perimeter, so 1/2 the apothem of 6.5 times the perimeter of 47. So I do 6.5 times 47, and I divide by 2, and I get 152.75, so I'm going to round that up to 0.8. Okay, so that kind of finishes up area of those figures. Now, we've got one other big idea left to talk about in this lesson. So as I move forward, this last big idea is the idea of composite figures. Now, composite figures are shapes that are made of multiple basic shapes put together. The word composite comes from the word compose, which means to put together. So to find composite area of figure shapes that are kind of stuck together without overlapping, we're going to find the area of each individual shape and then add them together. Okay. It's like this basic concept. Part plus part equals whole. Okay, we've been doing that a lot this year. All right, now there's another topic here we're going to look at. To find the area of a shaded region, like you'll see in examples 3 and 4, we're actually going to find the area of the outside figure, and then we're going to subtract the unshaded area. And I'll explain that as we go through those examples. But first, let's do numbers 1 and 2. Okay, so as I look at number 1 and 2 here, number 1, it looks like this figure is created just by a rectangle with a trapezoid underneath. So we've got the area of our rectangle plus the area of a trapezoid. That's what we're going to do. So the area of a rectangle, again, is just length times width. And the area of a trapezoid is 1/2 times height times the sum of the bases, base 1 plus base 2. So we got to look at our length and width of a rectangle. Well, that's easy to see. Length we can call 23, width we can call 12. So that's 23 times 12. I'll go ahead and simplify that now. 23 times 12 is 276. Okay, that's this part. But I have to add this part. Okay? So I need those dimensions. So I need 1/2 height times base 1 plus base 2. Well, I can call this one of my bases. I'll call it base 2. The other base is actually this side, which is the same as the opposite side of the rectangle, 23. So that's my base 2, or sorry, base 1. But the height measurement from here down to here That is not marked. However, we can kind of problem solve here. We know the overall height of the figure is 18 centimeters, right? Well, from here down to here is 12 because it's the opposite side of the rectangle. So all I have to do to find this side is to do 18 minus 12, which is 6. So the height of my trapezoid is 6. So let's start to fill that in. I'm going to do 1/2 of that height, 6, or 1/2 times 6, parentheses, base 1, 23, plus base 2, 15. And then I start to simplify. Okay, what I'm going to do, I'm going to kind of do 2 steps in one. Instead of waiting to the end to divide by 2, I could actually do 1/2 of 6. I could do the 6 divided by 2 first. Okay, that gives me just 3. Times, I'm also going to add 23 and 15 together, and that's 38. Okay. Give myself a little more room here. So when I do 3 times 38 now, I get 114. And so I'm going to add that to 276. Okay, so when I combine those two total areas, I get a grand total of 390 square centimeters because they give me the units of measure this time. Okay. All right, let's move on to number 2. Okay, on number 2 here, we actually have 3 different composite figures we're putting together, or 3 different simple shapes to create this one composite figure. We've got a rectangle, we have a triangle, and then we have a semicircle, or half of a circle. All right, so we're going to combine those areas. So let's go over our area formulas for each one. Rectangles are just length times width. Triangles are base times height divided by 2, or 1/2 base times height. But a half circle, we're just going to take that literally. We're going to do the area of a circle, pi r squared, and we're going to divide it by 2 to cut it in half. So let's start filling in what we know. So I've got this clearly marked side of my rectangle is 9, so that can be the length or the width. But the other dimension from here to here, I've got to figure out. Now, the overall height is 26. You guys can easily see that. However, to find this missing piece, I need to know the bottom piece to subtract from 26. So let's kind of look at this picture and see what we can figure out. Well, from the center to this side is also the opposite side of the rectangle, so that's 9. That ends up being the radius of that circle. Well, radius goes anywhere, so that's 9, and so is this. Now this side doesn't help me as much, that radius there doesn't really help me, but this one does. Okay, this radius here is the same as this length there, 9. So if I do 26 minus 9, I get 17 for the length or width of my rectangle. So the area of a rectangle is going to be 9 times 17. And now I can move on to the triangle. Let me simplify that first. 9 times 17 is 153. So the area of the rectangle is 153. Now let's look at our triangle. Okay, this can be my base and this can be my height because they are perpendicular to one another. Okay, they're at a right angle. So the base is actually still a radius of that half circle, 9. Now the height is not 9, but it's pretty close because to find the height measurement here, I'm going to do 17 minus 7. And that's 10. So my height measurement is 10. So my formula here is base 9 times height 10 divided by 2. Well, 9 times 10 is 90. When I divide that by 2, I get 45. So that's the area of the triangle. Now we can find the area of a circle. And I've already done a lot of that work in finding what the radius should be. We talked about that. The radius is 9. So that's going to be pi times 9 squared divided by 2. And I'm going to use my calculator for that. 9 squared is 81 times pi and then divided by 2 gives me an area of 127.2 for the half circle. Now I'm going to add all those up. I'm going to add 45 to that, and then also add 153 to that, and my total area for the entire figure is 325.2 square feet. Okay? All right, just a couple more examples and then we'll be done with this lesson. These are the examples here where we've talked about the shaded area. So to find the area of just the part of this shape that's shaded, I'm going to take the area of this rectangle and subtract the area of this triangle. Okay, we call this is a concept called negative space. We're going to treat this unshaded part as a negative amount and add that in. That's why we subtract. So the area of our rectangle, again, is just length times width, or 14 times 25, which is 350. But then we're going to subtract the area of this triangle. Now remember, base and height of a triangle are perpendicular. So the base is 25 and the height is 11. Okay, so if I do 25 times 11 and divide by 2, I get 137.5. So I'm going to subtract that from 350. And I get a final area of the shaded region as 212.5 square centimeters. Okay? All right, so I'm going to help you set up number 4 here. I'm going to do a little bit of help first, and I'm going to have you finish it on your own. For number 4, our basic shape is a trapezoid, our outer shape anyways, and we're going to subtract a half circle. Okay, so when I do this, when I do my trapezoid minus my half circle, I'm just going to find the area of my trapezoid, which is 1/2 height times base 1 plus base 2. And then I'm going to subtract pi r squared, or pi r squared divided by 2. Now, when I look at my trapezoid, I can clearly see the bases. Okay, the bases are 37 plus, or in 17, so I'm going to add those. But notice I left the height blank for a second because the height could be this line, or it could be this dotted line out here, which is also the diameter of the half circle, but it's not marked, it's not given. Now, you notice I put these 2 dotted lines in, and that creates a rectangle, okay, where one side is 17, and the opposite side would also be 17. That means this extra shape out here is a triangle. It's a right triangle, in fact. I need to know this side of that right triangle. I have this side. I'm actually going to use this side this time as the hypotenuse, or C. And I actually know this side now too because it's 37 minus the 17 from here to here, giving me 20. So I can use Pythagorean Theorem, a squared plus b squared equals c squared, to find my height. So if I use this, a I'm going to call h, so h squared plus b is that other leg, 20 squared, equals the hypotenuse, 25 squared. Okay, so let's do that. 20 squared is 400. 25 squared is 625. And so when, to finish solving this, I'm going to do minus 400 from both sides. And h squared is 225. And then don't forget your square root. That means h is 15. So the height of my trapezoid is 15. There we go. Now I can finish solving that out. And then I'm going to do minus the area of my circle, of my half circle. So minus pi times the radius of the circle squared. Now the radius is half of 15. Okay. Okay. This length there is the same as this diameter here. Remember, diameter is twice the radius, so we just divide that by 2. So I'm going to take that 15 and divide by 2, and I get 7.5. So the radius is 7.5 squared. I'm going to multiply by pi and divide by 2 there. So now I can start to simplify things here. So the area of, what I want you to do now, I want you to pause the video and try and finish these calculations and see if you can get a final answer. Okay, this is what we should get. If you need more time, pause the video. When I do my area of my trapezoid, I should get this. 405. And when I do the area of the half circle, I get about 88.4. So when I subtract, I get about 316.6 square inches. Okay. So that wraps up, or that finishes our lesson on area and composite area of basic 2D shapes.